A coding agent can follow every permission rule and still produce broken software. At the same time, it can produce code that looks completely plausible while attempting actions it was never supposed to take. Those are two different kinds of failure, and one feedback loop can't catch both of them. That distinction brings us to the central question. What does a coding agent need besides a good prompt to produce reliable software? The answer is a practical two-loop model. One loop controls what the agent may do. The other tests whether the result actually works. You need both, because permission to act and correctness of output are separate engineering concerns. An agent can remain inside every permitted boundary and still write incorrect code, or it can attempt to cross an established technical boundary, no matter how convincing its code might look. Reliability starts when we stop treating those two situations as if they're the same problem. Before either feedback loop can do its job, the agent needs a bounded assignment. Break complicated coding work into specific prompts with concrete requirements and examples. The point isn't to pretend that prompting is the whole story. It's to establish exactly what the agent is trying to accomplish before execution and validation begin. A vague request leaves the target unclear. A specific request gives the workflow something observable to constrain and something concrete to test afterward. State the required behavior. Include examples that make success easier to recognize. And if the work is complex, divide it into smaller, more specific pieces. Those boundaries become the shared foundation under both loops. The action control loop can govern execution against a known task, while the test feedback loop can evaluate the resulting behavior against known requirements. So before you control or test anything, make sure the job itself is clear enough to support both. With the job defined, place an action control loop around execution. Run the coding agent inside a sandbox, which constrains what the agent may do. Then, establish approval gates for actions that cross known technical boundaries. The basic sequence is straightforward. The agent proposes or attempts an action. The sandbox limits the environment available to it. And if that action would cross a boundary, approval is required before execution continues. The decision at that approval gate then feeds back into what happens next. This loop is about authority, not code quality. It asks whether an action falls inside the established operating space. Sandboxes and approval gates have related but distinct roles here. The sandbox creates constraints around execution. The approval gate introduces an explicit decision whenever the work would move beyond those constraints. Together, they create a feedback loop around what the agent is allowed to do. But this loop is only useful if you read its signal correctly. If an action stays within the sandbox, you've learned that it remained inside the configured execution boundary. If an action reaches a gate and receives approval, you've learned that the boundary crossing was allowed. What you haven't learned is whether the software produced by those actions behaves correctly. Neither outcome answers that question. And this control isn't a claim that a sandbox guarantees security or correctness. It doesn't. It's a way to constrain execution and require a deliberate decision at established technical boundaries. That's already valuable. But it answers only one precise question. Was the agent permitted to take this action? Keeping the question that specific matters. Otherwise, it's easy to mistake a signal about execution control for evidence about software behavior, even though the loop never evaluated that behavior in the first place. Now imagine the agent completes the entire job without crossing a single boundary. Every action was allowed. The run looks clean and orderly. Nothing appears to have escaped the established controls. And yet, the resulting code might still mishandle an edge case. It might behave incorrectly on a failure path, or it might conflict with the behavior of the surrounding implementation. That's the central complication. Passing an approval boundary means an action was permitted. Permission to act and correctness of output remain separate engineering concerns, even when the workflow itself feels controlled. An action control loop can reduce uncertainty about execution, but it can't evaluate every behavior introduced by a code change. Once the agent has acted, the workflow needs a different kind of feedback. This second form of feedback has to focus on what the software actually does, not simply on where the agent was allowed to operate. That second mechanism is the test feedback loop. Use AI to expand test coverage around the requested change. Include edge cases where inputs or conditions fall outside the most obvious path. Include failure paths where an operation doesn't succeed as expected. And derive tests from the surrounding implementation context, not just from the new code the agent produced. These tests provide feedback that action controls simply can't provide. The cycle is behavioral. Produce a change, run meaningful tests, observe where the behavior fails, and then use those results to guide the next revision. The goal is broader validation. It isn't a claim that expanded tests somehow make the software bug-free. Tests show whether important behaviors work under the conditions you chose to examine. That gives both the agent and the developer concrete evidence to use in the next iteration, instead of relying on the fact that the code merely looks plausible or ran successfully once. The phrase, expand test coverage, matters because a narrow test can only confirm a narrow slice of behavior. Begin with the concrete requirements and examples that define the job. Those should absolutely be tested, but don't stop at the easiest successful case. Add edge cases that challenge the boundaries of the expected behavior. Add failure paths that examine what happens when an operation can't complete normally. Then look beyond the change itself. Study the surrounding implementation context and derive tests for the ways this change interacts with nearby behavior. That produces a much stronger feedback signal than simply checking whether the new code runs one time. The test loop is valuable because it converts hidden behavioral assumptions into observable results. It doesn't authorize any action, and it isn't meant to. What it does is show where permitted work behaves as intended and where it doesn't. That's a fundamentally different signal from the one provided by a sandbox or an approval gate. Put the two loops side by side, and their different jobs become much easier to see. Sandboxes and approval gates constrain what the agent may do. Expanded tests reveal whether what the agent did actually works. Take away the action control loop, and the test still can't tell you whether an attempted action was authorized. Take away the test feedback loop, and permitted execution still can't establish that the resulting behavior is correct. One loop surrounds the agent's actions. The other surrounds the behavior produced by those actions. Both loops generate feedback. Allowed does not mean correct, and pass these tests does not mean authorized to execute. Reliable AI development needs both signals because each loop covers a failure mode that the other is structurally unable to answer. Neither loop is a substitute for the other, even when one of them appears to be working perfectly. So the complete workflow has 3 stages. First, define the work with concrete requirements and examples. Break complicated work into specific, bounded prompts so the target is clear from the beginning. Second, run the agent inside a sandbox and require approval whenever an action crosses an established technical boundary. That forms the action control loop around execution. Third, expand tests across expected behavior, edge cases, failure paths, and the surrounding implementation context. That forms the test feedback loop around the result. If those tests reveal a behavioral problem, revise the change and test it again, while keeping execution inside the same action controls. Reliability comes from the combination: a clear target, bounded execution, and behavioral verification. The prompt defines the job. The first loop governs the agent's actions, and the second loop evaluates what those actions actually produced. Each part answers a different question, and the full workflow depends on all 3 stages working together. Before you accept agent-generated work, ask 2 questions instead of 1. First, did the agent remain within its established boundaries, with approval required wherever those boundaries were crossed? Second, Did the resulting software pass meaningful tests covering the requirements, examples, edge cases, failure paths, and surrounding implementation behavior? If the answer is yes to only one of those questions, the picture is incomplete. Controlled execution can still produce incorrect code. And passing tests can't retroactively authorize an out-of-bounds action. This is the practical mental model to carry into your next agent workflow. Permission to act and correctness of output are separate engineering concerns. Trust should come from examining both loops and interpreting each signal for what it actually tells you. Don't ask one loop to answer the other loop's question. Check the boundaries, check the behavior, and understand why both checks matter. Now take a close look at your current coding agent workflow. Which piece is missing? Action control or test feedback? If execution is loosely bounded, add a sandbox and approval gates around established technical boundaries. If the changes are permitted, but only lightly validated, expand your tests across edge cases, failure paths, and the surrounding implementation context. Keep the job concrete by defining requirements and examples, and then confirm that both feedback loops are actually present. That's the payoff of the entire model. Define the task, constrain the execution, and verify the behavior. Each step has a clear purpose, and together they give you a much stronger basis for deciding whether the agent's work can be trusted. For more clear, practical deep dives into AI, software development, and open source, subscribe to NeuralStack. And if this two-loop model sharpened the way you think about your own workflow, share which loop you need to strengthen in the comments.